The future of contested logistics is autonomous. Air delivery systems, uncrewed surface vessels, autonomous ground vehicles. But autonomy creates a new problem. How do all of these systems remain connected and coordinated when the infrastructure they normally depend upon cannot be trusted? GPS may be degraded. Communications may be intermittent. Cellular, Wi-Fi, and cloud infrastructure may not exist at all. Yet autonomous systems still need to exchange mission data, coordinate movement, understand their relative geometry, and adapt as conditions change. That requires a different kind of network. Bleed.io developed MACF, the Mission Adaptive Autonomous Connectivity Fabric. MACF is a decentralized connectivity layer designed for autonomous systems operating at the tactical edge. Nodes discover each other, form the network, route data across the fabric, and dynamically adapt as platforms move, join, or leave the mission. No central hub is required for the local network. For autonomous, attritable air delivery, multiple aircraft can launch and establish a local MACF network without requiring a pre-planned topology. As aircraft maneuver, network routes adapt with them. Each participating platform can become part of the communications fabric, enabling distributed telemetry, mission data, and machine-to-machine coordination without dependence on a single gateway. The same architecture extends into the maritime domain. Autonomous surface vessels transporting supplies across contested littorals can maintain local machine-to-machine connectivity as geometry and link conditions change. Long-haul communications can connect the local fabric to higher-level command systems when available, without making every local interaction dependent upon reachback. At the destination, autonomous ground delivery systems continue the logistics chain. Vehicles become network nodes themselves, extending connectivity as supplies move toward dispersed forces. Vehicles, sensors, and operators can exchange information locally without requiring cellular infrastructure, fixed access points, or continuous cloud connectivity. Different platforms, different domains, one connectivity fabric. MACF's core networking behaviors are already demonstrable. Here, 12 nodes launch with no pre-planned network topology and no operator action. The mesh self-forms, establishes routes, and continuously adapts as network geometry changes. The network exists before the mission needs it. But MACF does more than carry traffic. The same radio link can also measure distance between participating nodes. That means ranging is not a separate system added alongside the network. It is a capability of the network itself. MACF can use these measurements to derive relative geometry among participating autonomous systems. That becomes particularly important when GPS is degraded. In this demonstration, GPS denial causes absolute position accuracy to deteriorate, and MACF reports that degradation rather than hiding it. But relative geometry remains stable, because participating nodes continue ranging to one another. The system may know less precisely where it is on Earth, while still knowing where its teammates are relative to one another. Contested logistics must also assume attrition. When a node is lost, MACF first reroutes communications around the failure. But network recovery is only part of the problem. Because ranging continues between surviving nodes, the remaining systems can also restore their relative geometry. The network heals, and the autonomous mission can continue. MACF is intended to complement existing Army communications and command systems, not replace them. Its role is the resilient local connectivity fabric underneath autonomous operations. Open interfaces provide a pathway for mission, logistics, situational awareness, and tasking data to move between autonomous platforms and Army systems, including TAC and higher-level command and control environments. Autonomous sustainment is not ultimately about a drone, a vessel, or a ground vehicle. It is about creating a resilient system of systems capable of moving supplies across domains while reducing risk and operator workload. Air, maritime, ground. One mission adaptive connectivity fabric. MACF. Productizing resilience, powering autonomous sustainment at the tactical edge.